Good morning. This is Mrs. Schaefer, and I wanted to share with you a quick video on Pascal's principles. So, the standard we're looking at is describing properties of matter, density, buoyancy, pressure, Pascal's principle, and Bernoulli's principle. You might have experienced this idea when you look at your toothpaste. Does it bother you when someone in your family doesn't squeeze from the bottom of the tube? The fact that you can squeeze it from the bottom and still have toothpaste come out is an example of Pascal's principle, and that's what we're going to be covering today. Review this. We need to know, as we're talking about fluids, we need to have a clear definition in our head. So what is a fluid? Did you list it was anything that flows? As a review, let's look before we jump into new material. Let's talk about which of these equations is the equation for pressure. Which one do you pick? Remember that anytime you press on anything, you're applying pressure. So the area, a larger area of pressure to press on is going to give less force applied to the whole area. Where like in our thumbtack, we have this tiny, small area that we're going to push force on. It's going to give us a greater amount of pressure. But our best choice for the formula on what pressure is B. Pressure is force divided by area. And pressure can be in a confined fluid. Confined meaning it's in a container. It's the same for pressure. Pascal's principle says that the pressure in the fluid is the same everywhere. At each point, there's the same amount of pressure. And here's some examples of this. If you increase pressure at any point in a confined space, you increase the pressure over all the parts of the container. Doesn't matter if it's in the tire or in a container like this. Here's some examples of Pascal's principle in action in the real world. Our braking system works on this example, along with elevators and some of these lifts or cranes. So here's some examples: pistons, hydraulic presses. Those are examples of Pascal's principle. So if we change the pressure anywhere in an enclosed fluid, the rest of the area is going to have a change in pressure also. And there is math applied to this. There's a video in your course that will explain it, that you'll want to watch. You don't have to practice the math, but I do want you to know that it applies, and you can see how this principle is applied in the situation, because we use it all the time. Automobile lifts, elevators, it follows the law of conservation of energy. What you put in must come out. So if you increase the force, in one area, it will decrease the distance that it needs to move it. So this is an example of a large piston. And you can see how this applies. So here is a smaller piston pushing down, and it's causing the larger piston to push up. But these are just some examples, and this is just a brief introduction to Pascal's principle. Go ahead and go in and take the practice test to see if you're understanding this idea. Check out that video, it will definitely help you. Catch up on any late or missing work. Please be sure that you're constantly checking your grades tab to make sure that you haven't missed anything. And the code word for today is up on the board. If you have any questions or concerns, please let me know. I want to share with you also some other helps that you'll want to pause this video for so that you can catch them. So I recommend that you make sure you have some pictures and some examples of what pressure is, and then about Pascal's principle. Here's some reading that will explain it. Definitely some good information here you'll want to use to help you out. Well, have a great day, and we will see you next time.